Hi guys, this is chapter 11, section 5, which is exploring solids. There's going to be a lot of vocab on this section. All right, so we start with a polyhedron. And a polyhedron is a solid bounded by polygons, and these are called faces. So if you remember, your polygons are closed shapes. They could be rectangles, rhombuses, squares, anything like that. Trapezoids, those would all be polygons. The vocab term there is faces. So when you look at the object that's in this example, every single side is called a face. The edge is the segment that's formed by the intersection of two faces. So this is an edge, this is an edge, an edge, an edge, an edge, an edge. All of those are edges. The vertex is the intersection of the intersection point of three or more edges. So this would be a vertex. Up here would be a vertex, 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 vertex. So all the corners are vertices. And the plural of polyhedron is polyhedra or polyhedrons. You can use either one. So again, just some vocab to get us started here. These are some of the more common types of solids that we're going to talk about in the next couple of sections. So these are polyhedra, a prism, and a pyramid, because a polygon can't have a curved edge. So these are called polyhedra, prisms, and pyramids. And these are not polyhedra, but they're still solids: cylinder, cone, and sphere. We're actually going to learn how to find the lateral area, the surface area of all of these objects, and then the volume. So notice the prism has, in this case, this is a rectangular prism. It has two what are called bases, like top and the bottom, and then the rest are the faces, where a pyramid only has one base, and then the rest are called lateral faces. If a prism was a circular prism, then it would be a cylinder, and if a pyramid was a circular pyramid, then it'd be a cone. And then we know spheres, which are like basketballs or the globe, anything like that. All right, so a prism is named by the shape of its base. Like we just said, a rectangular prism. This time, the bases are the hexagons. So this is pentagons. So this is a pentagonal prism. The lateral faces are the parallelograms formed by connecting the corresponding vertices of the bases. So each of these sides, here, 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 and then on the back side, those are called your lateral faces because they connect the bases. The altitude or height of the prism is the perpendicular distance between the bases. So one of the edges of the lateral faces, those would be heights or altitudes. They have to be little right angles. And the two bases are congruent polygons in parallel planes. So congruent meaning that they would be the same size. This is going to be the same size as this. Parallel meaning they'll never touch. That's because they are separated by these right angular or perpendicular segments. A pyramid, it has a base that's a polygon with n number of sides, n number of lateral faces that meet at the vertex. So this is a square. Well, it looks like it could be square or rectangular. Where that bottom is the base, that quadrilateral, there's the base, and because it has four sides, it's going to have four lateral faces, 1, 2, the back one, and this left one, four lateral faces, and they all meet at the point at the top, which is called the vertex. The altitude is again the segment from the vertex perpendicular to the base. So it's still perpendicular, but this time it's going to go straight from the vertex to the base. It's going to hit the base at the center of the base. And again, we name it by the shape of the base. So if this was a square on the bottom, then this would be a square pyramid. If this was a rectangle on the bottom, it would be a rectangular pyramid. So pyramid, one base, prism, two bases. Euler's theorem is something that you can use to help you check to make sure you know all the right number of vertices, edges, and faces. So the number of faces, which we're going to use F for, vertices and edges of a polyhedron are related by the formula called Euler's formula, which says F plus V equals E plus 2. So if I look at the cube that's here, if I counted the faces, there's one at the top, one on the front, one on the bottom, one on the left, one on the back, and one on the right. So there are 6 faces. If I counted the vertices, 1, 2, 3, 4, 5, 6, 7, 8, there are 8 vertices. The edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. And to check it or to prove it, we would say the faces plus the vertices equals the edges plus 2. Faces is 6, vertices is 8, edges is 12 plus 2, and I'd get 14 equals 14, which verifies we counted correctly. All right, example 1 says, tell whether the solid is a polyhedron. If it is, name the polyhedron and then find the number of faces, vertices, and edges. So remember, a polyhedron can't have a curve, which means A is yes, B is no, C is yes. Then I want to take the polyhedrons and name them. So this first one, this is a square on the bottom. All 4 sides are marked the same, so this is a square pyramid. And C, this and this are my bases. So this is a right triangular prism. And then find the number of faces, vertices, and edges. So for A, we've got the bottom, the front, the left, the back, and the right, which means there's 5 faces. 1, 2, 3, 4, 5 vertices. And 1, 2, 3, 4, 5, 6, 7, 8 edges. Now look at C, faces. There's the 2 triangles, 1, 2, and then the one on the left, the one on the bottom, one on the top. That's 5 faces. 1, 2, 3, 4, 5, 6 vertices. And 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And then remember, we can use Euler's theorem to check. So 5 plus 5 equals 8 plus 2, and 10 equals 10. That works. And 5 plus 6 equals 9 plus 2, 11 equals 11, which also works. A cross-section is the intersection of a plane slicing through a solid. So if you could picture your pyramid, which is the original shape here, and you took a plane and you just slid it through your shape, the intersection of that plane and your polyhedron is called the cross-section. So in this case, this cross-section is actually a triangle. They're going to take on different shapes. But that's what's called a cross-section. If I had actually taken it and chopped it off at that point, what would the shape be that I'm looking at? And that would be a triangle. A, this is example 2, says describe the shape formed by the intersection of the plane and the solid. So they're actually kind of color-coded here for you. It's where the yellow, or where the pink meets the blue, looks a little purple. And this would be a square or a quadrilateral if you're unsure if they're all the same. This appears to be a rectangle. Again, it could be a rectangle. You could call it a quadrilateral. You could call it a parallelogram. This shape is a trapezoid. This is a triangle. And this is a circle. Okay, that's it for 11.5. So a pretty short section, which is why you're doing that and the surface areas together. So the next video you want to watch is the surface areas of a prism and a pyramid. Good luck and have a great day. Make sure you submit your notes for these. For both 11.5 and surface area of pyramids and prisms. They can be two separate files, but you do want to submit them both.